Spearman's rank correlation. Okay, so there are three measures of correlation. We have studied two measures. First one, scatter diagram. Then second one is Karl-Pearson correlation of coefficient. Okay, and third one is this is Spearman's rank correlation. Okay, so this is Spearman's rank correlation. So what is the need of the Spearman's rank correlation? Okay, so we also denote it by this symbol, or sometimes in some book capital R is there, but I will refer you to use this rho symbol. What is this called? Rho. Okay, in Marathi you can read rho. Okay, so what is the need? Now, actually, Karl-Pearson correlation coefficient means correlation between means the previous formula you have applied. It can be applied to only quantitative data. Quantitative data. Okay. Suppose marks of students in two subjects, right? Or marks of students in two divisions. So when you have quantitative data, I mean numerical data, definitely this is the best choice. But sometimes this is not the case. You have qualitative data. Qualitative means numerical data. Qualitative means non-numerical data. Okay. For example, I say judges are there A and B, and suppose there are participants 1, 2, 3, and 4 in a singing competition. Suppose this is a singing competition. Now, what the judges do? They rank you. Okay, they give you rank first, second, third, and fourth, and fifth. Okay, so judges are doing this independently. So in that case, what they are doing, they are observing the quality, which is not measurable actually. Okay, quality, they are means attribute you can say. So they are measuring the quality and then converting into some criteria, or they are giving them some rank. Okay, and then analyzing it. So in short, when there is a qualitative data, then in that case you use the Spearman's rank correlation. Okay, so understand this. So in this case, we rank the observations in some order, either increasing or decreasing. Okay, but you have to do same way for both the data. Suppose you chose to do the ranking in an increasing way, then both the variables you have to do in the increasing way. If you chose to do the ranking with the decreasing, then you have to keep the same format for both the sets. Okay, so now let's come. There are two methods. There are two cases in the rank Spearman's rank correlation. Okay, so did you understand what is the need of this? For quality, for qualitative data, or where there is a merit, when there is a merit there. Okay, सिंगिंग कंपटीशन में इसका फर्स्ट है, उसका सेकंड है, इस तरह से अगर कहीं डेटा है, so in any competition, judge your quality and then give you merit. If your quality is very good, then you are given the highest merit, right? So in that case, you use the Spearman's rank correlation, and Karl-Pearson rank correlation is not possible in that case. Okay, so when in short, when there is a quantitative data, you definitely use Karl-Pearson, and if it is not, if it is qualitative data, you use the Spearman's rank correlation. So now there are two cases, of which the case one, different ranks. Okay, so different ranks are there. Okay, so let's try to understand this one. Different ranks means, suppose X is having some values, Y is having some values. Okay, so suppose I write some random values, right? So Suppose these are the runs made by cricketer. Okay, so cricketer X and cricketer Y in innings, first inning, second inning, third inning, in 5 innings. Okay, so these are the runs made in different innings by two cricketers. Suppose Virat Kohli and Rohit Sharma, right? Okay, so 55, 48, 102, 8, and suppose 100. Acha. Suppose this is 74. This is some of the one of the. Suppose this is another cricketer 60, 45, 98, then 102 and 100. This is another player. So what you do, आप इंक्रीजिंग ऑर्डर में रैंक देने वाले हो, तो वही सबके लिए आपको ये करना पड़ेगा. तो इसमें कोई भी रन यहाँ पे जो है ये सेट के अंदर में कोई भी रन जो है वो रिपीट नहीं हो रहा है. नन ऑफ द वैल्यू इज रिपीटिंग. सी कोई वैल्यू रिपीट हो रही है यहाँ पे 55, 48, 102, 8 एंड 74. नो, here also all values different. So you are saying different rank. तो सबके ranks भी क्या आएंगे, different आएंगे. Rx and Ry, rank of X, rank of Y. Okay, so अब हमने increasing order से देने highest जिसने ज्यादा रन बनाए उसको first rank देंगे. ठीक है, तो ये first rank हो गए. Okay, in this series this is the second rank, this is the third rank, this is the fourth rank, and this is the fifth rank, right? Now here in the second data, it will be first rank, it is the second rank, this is the third rank, this is the fourth rank, and this is the fifth and final rank. Okay, then what you do, you find the, now you apply the formula. Okay, so in that case, you use the formula, you find out the difference. Okay, so difference in the ranks, Rx minus Ry. Okay, you find the difference between the ranks, Rx minus Ry. So then you find the difference. So minus 1, this is minus 1 again, this is minus 2, this is 4, and this is 0. Then you find the square of the difference. Okay, so 1, 1, 4, 16, 0. And you are interested in the sum of the difference and some of the squares of the difference, right? So it is how much? It is minus how much? Okay, it will nullify, it will be 0. Good. Okay, so in such case the calculations are very great. Okay, actually you don't need this summation di, you need this one. So here it is 22, and we use a formula here. Remember the formula. So when there is no tie or different ranks are there, when you get different rank, when you will be having different observations, no repeating. That, so what is the formula in that case? So Spearman's rank correlation is 1 minus, remember it is 6 and not sigma, summation di square upon n into n square minus 1. Okay, so now 1 minus 6 into what is the summation di square? It is 22 upon what is n? It is n is 5 because there are 5 sets of values. 5 innings are there, right? Okay, so it is 5 into 5 square minus 1. Go on simplifying this, you will get the answer. So 1 minus to this. Okay, so 22 into 6, it is 132 upon, okay, I write the final value here. Yes, 24 into 5, it is 120. So what is the final answer? So it is 132 divided by 120. So 1.10. So 1 minus answer. So it is minus 0.10. Okay. And now again, you interpret here. What you interpret here? What you interpret? There is a negative correlation between the values. Okay. During the run scored by the both the batsmen in 5 innings. Okay, or simply you write there is a negative correlation, that is enough. There is a negative, but your interpretation is important. There is a negative correlation. All of you understand? Yes or no? If you understand it, please blow your thumbs. Okay, very good. So this is the uh, rank correlation with no ties, means different ranks are there. Different observation, different rank. Now we'll discuss the case number 2. So this is very important. I think this is the thing you need more explanation. Okay, so be alert. Case 2. So tied ranks or repeated ranks, whatever you say, but ranks are repeated over here. Okay, so I'll discuss that one. Uh, Repeated rank or repeated ranks or tied rank. Tie means when both the two students get the same mark, we say there is a tie. Or when both the teams score the good same runs, you say there is a tie, right? The same meaning. So let's take an example. Better I speak, I do it. Okay. So I have some set of values. I take a very small data, right? So X and Y I'm taking, and I take some values there, 50, 54, 54 again, 61, and 50 again. Okay. So I'm taking a small data. No matter how big it is, the important is how well you understand it. So size of the data is small. So some another data I am taking here, 45, 49, 50, 55, and again one of the value repeats over here also. So this is the data. Now again I'm finding the ranks, and now in this case I need to do some homework, right? What I do, I arrange all the values of X here, or I write here. I write all the values in the same, in the increasing order, or the order in which I want to give the rank. Okay. So highest value I will write first. Okay. So what I'm write here, highest value is 61. Okay. 61. After that, it is 55. Again 55. Sorry, 54. Then 50 and 50. Now you observe that two values are repeated, right? And I cannot give. Now see their ranking. Let me arrange y also. Arrange the y in the same way. Highest value first. So 55, then 50, then 49. Okay. Then 45 and 45, right? So now let's now looking at the sequence, there should be 1, 2, 3, 4, 5, right? But what you observe that here, second and third ranks are repeated. This is also repeated. So in that case, we put the average. So this will be 1, but this observation at second and third will share their ranks. So average rank is what? Second and third divided by 2 means 2.5. So in this case, you will share the rank here, 2.5 and 2.5 here. Similarly, 4 and 5, they will share the rank 4.5 and 4.5. Did you get it? If you understand, please blow your thumbs here. I need your response. Okay, good. Now here, basically there should be rank like this. There should be rank 1, 2, 3, 4, 5. But what's happening? Now these first three values are okay because these are different. But here, again, there is a sharing. So you cannot give the same number different ranks, right? So you have to share it. So it is 4.5. It is 4.5. How did you get? 4 plus 5 divided by 2. You are sharing the rank this way. Okay, so this work you have to do before you give the ranks. If you do this one, then your work get very easy. Okay, so spare some time for this while solving uh, of case 2 problem, repeated rank problem. Okay, so now put the, see the number and put the rank there, 50 in the first set. What is that? 4.5. Here also 4.5, then 54, 2.5, here 2.5, and 61 will be sharing the rank 1. Okay, now what about this one? Now 45 will be sharing the rank 4.5. Here it will now 49 will be having rank 3. Then this one is having uh, 50 is having second rank. Then 55 is having the first rank, and this one 45 is having 4.5. There is no relation between 45 and 4.5. Okay, this is totally upon the ranks. Okay, so there is no logic that there is 45, there's by divided by 10, there is 4.5. No logic there. Okay, the logic is here, this one. Okay, then again, now steps are same. You have to find out the difference, rx, ry, or ry minus rx, whatever, because ultimately we are needing the squares, so it doesn't matter. Square of positive number is positive, square of negative number is negative, so it doesn't matter really which way you take. So it is 0, it is minus zero point 0.5, this is what, zero point 0.5, this is 0, and this is 0. So see the difference, square, this is, it is 0.25, it is 0.25, again it is 0, it is 0, and you want the summation di square here. Okay, so it is 0.50. You understand this? Okay, but we have this is not the end. So here we have to find out a correction factor. Okay, so you have to create one more table here. So now I will give you the formula. So what is the formula for that? So it is, so formula is, it is rho is 1 minus 6. Now here what I'm writing, see it properly, 6 into, now see, 6 into summation di square plus, to reduce your confusion, I am writing here a correction factor over here, upon n minus, sorry, I'm adding some correction factor here, n square minus 1. But you should quickly write down what is correction factor. So correction factor is, it is summation m into n square minus 1 upon 12. Okay, you must write this. So usually in the formula, this entire term is here, but it may create a problem to you. That's why I have called it as a correction factor and explain what is correction factor formula here. I have read from 1 to n. Now one more thing, one more question arises. What is m? Okay, so number of times a value is repeated. Number of time value or observation is repeated, irrespective either in x or y. Okay, value is repeated. So how many times it is repeated, that count. Okay, so as I said, this is the formula. Okay, you can also put this correction factor instead of this correction factor, you put this formula, you will get the answer. Okay, you will get the formula. But I want to show you that this is similar to what case 1. क्या similar है? जब repeat नहीं होता है, डिफरेंट होता है. जब डिफरेंट होता है तो क्या होता है, ये करेक्शन फैक्टर क्या होता है, 0 होता है. सी इफ यू पुट 0, ये फार्मूला बन जाएगा, ये फार्मूला बन जाएगा नॉर्मल वाला. ठीक है, पर जब सेम होता है, रिपीट होता है, इट हैज सम वैल्यू, दिस इज ग्रेटर देन 0। ओके, बस यही बात आपको एक्सप्लेन करना था, इसलिए मैंने जो फॉर्मूला है उसको थोड़ा सा मॉडिफाई, आई हैव मॉडिफाइड द फॉर्मूला। ओके, so when it is no difference 0, so you will get the formula summation di square upon n into n square minus 1 and all. Okay, but when there is repeated, there exists some difference. So now let's find out this correction factor. Okay, very simple. Now I need to do this here only because the original data is here. Okay, are you able to see this properly? Okay, I need to utilize the space over here. Okay, so if it is congested, please understand. Now I want this correction factor. What is my aim? What is this correction factor, right? What is the formula? Summation m into m square minus 1 upon 12. Okay, this is, so very simple. This is the table number 2. You have to, suppose I call it 1, table 1. So this is table 2. Okay, so now I have to write m. Now in x, what is repeating? X में क्या repeat हो रहा है? 50, right? Better I write here. I write m here. Okay. Okay. X के अंदर में क्या repeat हो रहा है? What is repeating in x? Two values are repeating. First 50 and then 54, right? Y के अंदर में क्या repeat हो रहा है? Are you getting my point? Y के अंदर में क्या repeat हो रहा है? 45. Blow your thumbs. अब देखो कि x के अंदर में ये 50 कितने बार आया? Yes. M is equals to 2 when this is concerned. So M1 is this one, right? 54 is also repeating twice. So M2 is 2 again. And 54 is also repeating. So this is nothing but M1, M2, M3, right? Okay. Now what you do? You do a simple thing. You get this total. M into M square minus 1 upon 12. एक करके बताता हूँ मैं. I'll do 1. So M is 2. 2 square means 4. 4 minus 1 upon 12. Right? So it is 2 into 3 upon 12. So 6 by 12. So how much this? So this is 0.5. So similarly, you will get here 0.5, here 0.5. Got it? Because M is same here. 50 के लिए भी 2 है, 54 के लिए भी 2 है, 45 के लिए भी 2 ही है. So number of times, how many times is it repeating? All the three values are repeating 3 times. Sorry, 2 times. All the three values are repeating 2 times only. Okay, so understand. Now get the total. So this is m into m square minus 1 upon 12. So ये total करो, 0.5 plus 0.5 plus 0.5, it is 1.5. So this is the correction factor you have to add. Okay, so now we'll use the formula. Just note down this 0.5 here, summation di square, and summation, and this total you have to remember, these two things you have to remember. Okay, so correction factor हमने find out कर लिया है. अभी मैं यहाँ पे फॉर्मूला के अंदर में पुट करता हूँ. Okay, I erase this. Okay, hope you understand it very comfortably. Okay, so 1 minus 6 into, what is summation di square? 0.5 plus what was the correction factor there? Repeat होने की वजह से ये correction करना पड़ा. And there here values are 5, 5 square minus 1. Just solve this. So 1 minus, how much that? 0.5 into 1.5, 2. 2 into 6, 12 upon. And what is this? 24, 25 minus 1, 24. 24 into 5, 120. So 1 minus 0.1. So how much? 0.9. So there is a positive correlation between this. Did you understand this? So must interpret there is a positive correlation. Okay, I am writing in short because of time and space, but you have to write full interpretation. Okay, so I hope you understand this. So I end this topic here. Thank you. Hope you understand. Please blow